John Muir Health, Walnut Creek Campus, Sterile Processing Department, Decontamination Series, Ultrasonic Cleaners, Part 2 of 2. Before the first load is run, or when the water is changed, the ultrasonic cleaner must be degassed. The excess bubbles that are formed during the filling will reduce the energy the bubbles will release when they implode. Too many bubbles will absorb the sound waves. Starting from an empty cleaner, start an empty cycle and run for 10 minutes. This will allow for extra bubbles to dissipate before starting a load of instruments. The first step before any subsequent cleaning process, including the ultrasonic cleaner, is manual cleaning. All visible soil must be removed before placing the instruments into the ultrasonic cleaner. The ultrasonic is not meant to be a pre-cleaner or a soak tank. The ultrasonic cleaner will only function as designed if gross soil is removed. Gross soil absorbs sound waves and will reduce the cleaning action. Gross soil will also cover crevices and not allow the cavitation to reach those areas. Sound wave absorption. Let's test it. Let's see how sound is absorbed. Pause this presentation. You will need 1 cup, 1 rubber band, 1 towel. Once you have these items, restart the presentation. Wrap the rubber band around the cup lengthwise. Then pluck the rubber band and listen to the frequency and amplitude. Pay attention to the frequency. Is the tone high or low? Then listen to the amplitude. How loud is the sound coming from the cup? Now remove the rubber band. Place a blue towel inside the cup. Wrap the rubber band back around the cup. Pluck the rubber band and listen to the frequency and amplitude. How did the frequency change? How did the amplitude change? Did you find that the frequency and amplitude both went lower? This is the sound waves being absorbed by the blue towel. Gross soil is not the only sound-absorbing material. Below is a list of materials that should not be put in the ultrasonic cleaner: plastic, cork, rubber, glass, and wood. Lead, chrome, and ebonized instruments should not be placed in the ultrasonic cleaner, alone or with other metals. Lead is a soft metal that will be damaged by ultrasonic cleaning. The coating that give an instrument the chrome or ebonized look will be damaged by the ultrasonic cleaner. Mixing metals such as stainless steel with aluminum, brass, copper, titanium, anodized aluminum may cause color migration and/or oxidation. Electrolytic corrosion, or electrolysis, occurs when dissimilar metals are in contact in the presence of an electrolyte, such as water, or any moisture. When any two metals in the galvanic table are in contact with an electrolyte present, the one with the lower number is corroded. The galvanic action increases as the metals are farther apart in the galvanic series. For example, if we take bronze and mix it with steel, the steel would corrode because it is lower on the galvanic scale. After manual cleaning, all lumened or cannulated instruments must be filled or primed with fluids so the cavitation process can be effective inside the lumen. What is priming? Priming is the filling of a lumen or cannula with a cleaning solution until the air is removed. Why do we do this? This instrument was not primed. What didn't happen during this cycle? Because air was not displaced, there was no cavitation happening in the area that was absent of fluid. This instrument was primed. Do you see the difference? The instrument was filled completely, so the cavitation action will happen throughout the inside of this instrument. Instruments should be placed in a basket of small wire construction with at least 8 openings per inch to allow transmission of ultrasonic sound waves. Plastic or solid-sided pans are not recommended. Plastic will absorb the sound waves, and the solid-sided pans block sound waves. All instruments must be completely submerged in the solution, so they are exposed to the cavitation process. The picture below is an example of instruments not completely submerged. Water is the medium that carries the bubbles that create cavitation. If the instruments are not submerged, they will not be cleaned. All hinged instruments should be cleaned in the open position. Cavitation does get into crevices, but we want to help this action by opening and giving access to as much of the surface of the instrument as possible. After cavitation, rinsing is necessary to remove any residue, including detergents that remain on the instruments. This step is very important as the ultrasonic cleaner breaks up and pulls out contaminants, but has no rinse cycle. The instructions for use, or IFU, of most surgical instruments recommend ultrasonic cleaning as an integral step in the preparation for terminal sterilization. Manual cleaning is difficult to standardize and can vary in effectiveness from person to person. In contrast to manual cleaning, ultrasonic cleaners are automated and standardized and designed to clean surfaces that might otherwise be inaccessible. For the identified reasons, we must use the ultrasonic cleaner as one of the 3 steps of cleaning before assembly.